Okay, in this video, we're going to look at acid, bases, and salts. So we'll start with acid. So what is an acid? An acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. It is a substance, it is any substance, right? Which, when dissolved in water, when you dissolve it in water, it produces hydrogen ion as the only positive ion. Right? So for example, hydrochloric acid, HCl, is an acid, right? When you dissolve this acid in water, it ionizes to produce hydrogen ion and OH ion. And hydrogen ion is the only positive ion here, so therefore, HCl is an acid. Again, an acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. So when hydrochloric acid dissolves in water, it ionizes to produce hydrogen ion and hydroxyl ion, and this is the only positive ion that is produced in the solution, right? Also, when acid like tetraoxophosic acid, H2SO4, when it dissolves in water, it ionizes to produce hydrogen ion and tetraoxophosic ion, right? And this is the only positive ion that is produced. So an acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. Also, we can also have ethanoic acid, CH3COOH. When this compound dissolves in water, it ionizes to produce hydrogen ion and ethanoate ion, right? So this is the only positive ion that is produced in the solution. So again, an acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion, right? So if we want to represent the water in the solution, we can say that an acid is any substance which, when dissolved in water, produces hydronium ion, also known as the ozonium ion, as the only positive ion. For instance, when hydrochloric acid dissolves in water, H2O, when it dissolves in water, it ionizes to produce hydronium ion, H3O+, right? This is hydronium ion and chloride ion, and this is the only positive ion in the solution. So again, an acid is a substance which, when dissolved in water, produces hydronium ion, also known as ozonium ion, as the only positive ion. So when hydrochloric acid dissolves in water, it produces this ion as the only positive ion. It is the only positive ion here, right? Also, when tetraoxophosic acid, H2SO4, when it dissolves in water, it produces hydronium ion and what? Tetraoxophosic ion. And this is the only positive ion in the solution. So H2SO4 is an acid, right? So is this equation balanced? I have two hydrogen here. I have two hydrogen here, making it 4 hydrogen. And I have 3 hydrogen here. What am I going to do? Let me put 2 here. So I have 2 times 3 hydrogen here, which is 6, right? I have 6 hydrogen here. And then these 6 hydrogen, I have 2 here, I have 2 here. So if I put 2 here, I will now have 4 hydrogen here, 2 hydrogen here, making it 6 hydrogen, 6 hydrogen on this side. I have 4 oxygen here, plus 2 oxygen here, which is what? 6. So 6 oxygen. So I have 2 oxygen here, 4 oxygen here, making it 6. 1 sulfur, 1 sulfur. So the equation is balanced. So again, an acid is any substance, or is a substance which, when dissolved in water, produces hydronium ion or ozonium ion as the only positive ion. So when you dissolve H2SO4 in water, it produces 2 molecules of what? This ion, hydronium ion. This is the hydronium ion, also known as the ozonium ion, right? So To take us further, let's look at the different definition of an acid. There are different definitions of an acid. So the first definition we're going to look at is the general definition of an acid. So the general definition of an acid defined an acid as a substance which, when dissolved in water, produces hydrogen ion as the only positive ion, right? So for example, when HCl, hydrochloric acid, dissolves in water, it ionizes to form hydrogen ion and what? Chlorine ion. And the hydrogen ion is the only positive ion. So that makes it an acid. Also, when triazonitrate 5 acid dissolves in water, it produces hydrogen ion and what? Triazonitrate 5 ion. And this is the only positive ion that is produced in the solution. So according to the general definition of an acid is a substance which, when dissolved in water, produces hydrogen ion as the only positive ion, right? So it is the only positive ion that is produced here, and hydrogen ion is the only positive ion that is produced here. So these two substances, they what? They are what? They are acids. So what makes any substance an acid, according to the general formula, is the presence of what? Hydrogen ion. So another definition of an acid is according to Arrhenius, right? So we have Arrhenius' definition of an acid, and he defined an acid as a substance which, when dissolved in water, produces hydronium ion or ozonium ion as the only positive ion, right? So when acid like hydrochloric acid, when this substance dissolves in water, it produces hydronium ion. This is the hydronium ion, H3O plus, and chloride ion. And this is the only positive ion that is produced. An acid, according to Arrhenius, is a substance which, when dissolved in water, produces hydronium ion or ozonium ion as the only positive ion. So this is the only positive ion that is produced, right? Also, when triazonitrate 5 acid dissolves in water, it produces hydronium ion and what? Triazonitrate 5 ion. And this is the only positive ion that is produced in the solution. So this is what? An acid. So an acid is a substance, according to Arrhenius, is a substance which, when dissolved in water, produces hydronium ion as the only positive ion, right? So let's look at the other definition of an acid, which is according to Bronsted-Lowry, right? Bronsted and Lowry's definition. So according to Bronsted and Lowry definition, an acid is a substance that donates a proton to another substance, right? So if you look at this reaction, hydrochloric acid reacting with water, it donates this hydrogen. A proton is an hydrogen ion. That's what a proton is. So it will donate hydrogen to this what? Water. So to produce chloride ion and hydrozonium ion. So an acid, according to Bronsted and Lowry's definition, is a substance which donates, or a substance that donates a proton, which is hydrogen ion, to another substance. So this hydrochloric acid is donating hydrogen to this water to form hydronium ion, right? And chloride ion will be formed. Also, when substance like also hydrochloric acid reacts with ammonia, this hydrochloric acid will donate hydrogen to this ammonia, and when it donates it to it, it will form ammonium ion and what? And chloride ion. So the catch here is that, according to Bronsted and Lowry's definition, an acid is a substance that donates a proton, that is a hydrogen ion, to another substance, right? So the last definition of an acid we're going to look at here is the Lewis definition of an acid. And Lewis defined an acid as a substance that accepts a lone pair, a lone electron pair, or a lone pair of electron. So Lewis' definition of an acid, he defined an acid as a substance that accepts a lone electron pair, right? So when this is boron trifluoride, when boron trifluoride reacts with ammonia, this substance will be formed. This substance is known as trifluoroammonia borane. Trifluoroammonia borane. So which substance is the acid here? Boron trifluoride is the acid here. Why is this the acid? Because it is the substance that will accept a lone electron pair. It will accept a lone electron pair from the ammonia. So let's look at an illustration of that. So this is boron, right? Boron contains 5 electrons. It is the number 5 element in the periodic table. Hydrogen, helium, lithium, beryllium, boron, right? So that's number 5, and so it has 5 electrons. So if we are to write out the electronic configuration of boron, we're going to have this. The first shell will be filled with a maximum of 2 electrons, which we can see here, and then we have 3 electrons remaining, which is 1, 2, 3, right? So there are 5 electrons here in total. 1, 2, 3, 4, 5. This is the electronic configuration of boron, right? So, and we have fluorine. Fluorine is the number 9 element, and so it contains 9 electrons, right? So if we are to configure that 9 electron, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 electrons here, right? So this is the electronic configuration of fluorine. So when these two elements combine together, they will form boron trifluoride, right? Boron trifluoride. What does that tell you? There are 3 elements, or there are 3 atoms of fluorine in this compound, right? There are 3 atoms of fluorine. So this is fluorine, this is fluorine, this is fluorine, right? This is fluorine, this is fluorine, this is fluorine, and this is what? The boron, right? So fluorine has just 1 electron that is not paired in its outermost shell. So this 1 electron will come here and bond with this. Another fluorine atom with this 1 electron will come and bond with this. Another fluorine atom with this electron will come and bond with this, and that is how we have this bond here, right? So this is boron trifluoride. So if you look at this compound very well, you will discover that this shell has 1, 2, 3, 4, 5, 6 electrons, remaining 2 electrons to make it an octet, to make it to be in that octet state with 8 electrons, right? So we can say that this element, or this compound rather, this compound is electron deficient. This compound is electron deficient. What does that mean? There is a space here that can still take 2 electrons, that can still take a pair of electrons, right? Because normally you are supposed to have, for it to be in an octet state, you are supposed to have 8 electrons here to make it to be in that octet state, right? But now we have just 6 electrons. So this compound here, boron trifluoride, is electron deficient, right? So this is the electronic configuration of ammonia, right? This is ammonia, NH3. Well, nitrogen is number 7 of the elements in the periodic table, right? So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. So it's number 7, and so it will have 7 electrons, right? It will have 7 electrons. So if I'm to write out the electronic configuration of nitrogen, I have this. The innermost shell will take a maximum of 2 electrons, and then remaining how many electrons? Remaining 5, right? So 1, 2, 3, 4, 5, right? So this is the 7 electrons that makes up nitrogen. 1, 2, 3, 4, 5, 6, 7. 7 electrons, right? So when nitrogen, this is nitrogen, when it bonds with hydrogen to form ammonia, there are 3 atoms of hydrogen in ammonia. Hydrogen is number 1 element in the periodic table, and so it has a maximum, it has just 1 electron, right? So this is hydrogen. This is just the electronic configuration of hydrogen. So you would need 3 hydrogen to bond with nitrogen to form ammonia, right? So this is nitrogen, this is hydrogen, and this is nitrogen. So you are seeing this hydrogen here with this 1 electron will come and bond with this. Another hydrogen with 1 electron will come and bond with this. Another hydrogen with 1 electron will come and bond it with this, right? To form ammonia. So this is what you see here. This is hydrogen, this is hydrogen, this is hydrogen bonding with this single electron that was here, 1, 1, 2, 3, right? To form ammonia. So you can see this compound, it is having this electron that is not bonded to hydrogen, right? This is what you refer to as a lone pair of what? Of electron. A lone pair of electron, or electron pair, right? So this is a lone pair of electron because it is alone. It is not bonded to hydrogen, right? So this compound is electron sufficient. Ammonia is electron sufficient. You can see this octet state. There are 8 electrons here in this atomos shell. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So boron trifluoride is electron deficient because it does not contain 8, right? So when this ammonia then reacts with boron trifluoride, this ammonia will come here and share this lone pair of electrons. This electron that is alone, it will share it with this space, with the boron trifluoride in this space, right? So this is the boron trifluoride. You can see this space here, no electron. So the ammonia that is electron sufficient will come here and bond with this compound to form this compound, right? And this compound is known as trifluoroammonia borane, right? So it is accepting, the boron trifluoride is accepting that lone pair of electron, and that is why it is called what? An acid. So according to the Lewis definition of an acid is a substance that accepts a lone electron pair or a lone pair of electron, right? So we've illustrated that here. Let's still look at it here again. This is ammonia. It is electron sufficient and it is having a lone pair of electrons. So this is the lone pair of electron, right? This is the lone pair of electron. It is alone. And this is boron trifluoride. You can see that this part here does not contain electron. So this compound is electron deficient, right? And this compound here is electron sufficient. So what happens is that this ammonia will donate this lone pair of electron to this compound, which is boron trifluoride. So the boron trifluoride will accept this lone pair of electron, it will accept it to form this compound. And so boron trifluoride is referred to what? An acid. It is called an acid because it is electron deficient and it can accept a lone pair of what? Of electron. So that is why boron trifluoride is an acid and it is called a Lewis acid, right? So Lewis definition of an acid. An acid is a substance that accepts a lone pair of what? of electron, and this is just an illustration, a chemical equation that illustrates it. So having known that, let's look at this question. Which of the following substance is an acid? Which of the following substance is an acid? So, like we said before, an acid is any substance, according to the general definition of an acid, is any substance that dissolves in water to produce hydrogen ion as the only positive ion, right? Or it dissolves in water to produce hydrozonium ion as the only positive ion. So when this compound, this is sodium hydroxide, right? When this compound, sodium hydroxide, when this compound dissolves in water, it ionizes to produce sodium ion and what? Hydroxyl ion or hydroxide ion. So this is the only positive ion produced. This is not an acid, right? Then we have HCl here. When HCl dissolves in water, it ionizes to produce hydrogen ion and what? Chloride or chlorine ion. So this is what? An acid, because this is the only positive ion that is produced. So our correct answer is what? HCl, which is called hydrochloric acid, right? Or hydrogen chloride. So ammonia, is ammonia an acid? No, because when ammonia dissolves in water, if I should represent that well, when it dissolves in water, it dissolves to produce ammonium ion and what? OH ion. So it is not an acid because this is the only positive ion that is produced here. So when potassium hydroxide reacts, dissolves in water, potassium hydroxide, when it dissolves in water, it dissolves to, it ionizes to produce potassium ion and hydroxide ion, right? And this is the only positive ion produced. So this is not an acid. So the correct answer to this question is what? HCl. Which of the following molecule has a lone pair of electrons on the central atom? Which of the following molecules has a lone pair of electrons on the central atom? So we've already looked at the elements that have a lone pair of electron, right? The compound that had a lone pair of electron, and we talked of ammonia. So ammonia is having a lone pair of electron. If you should draw the structure of ammonia, right? This is hydrogen. You have three hydrogen, right? So this is hydrogen, this is hydrogen, right? This is hydrogen. So this is the electronic configuration of hydrogen, right? Then if we should draw the structure of ammonia, the innermost shell will take a maximum of 2 electrons, and then outermost shell will take a maximum of 8, but nitrogen is number 7 element, so it will contain 7 electrons, right? So 1, 2, 3, 4, 5, 6, 7, right? So these are the 7 electrons. So when this hydrogen comes here, it bonds with this, right? So this is the hydrogen here. When this hydrogen comes here, it bonds with this. This is the hydrogen. When this hydrogen comes here, it bonds with this, right? So this is the hydrogen. So bonded with this electron here. So this electron that is not bonded with hydrogen is referred to as a lone pair of what? Electron. It is referred to as a lone pair of electron. What does that tell you? That the electron is a lone. Is a pair. A pair means two things together, right? So is a lone pair of what? Electron. So the correct answer to this question is what? Option C. Then which of the following compound is a Lewis acid? So what's the definition of a Lewis acid? Is any substance that what? Accepts a lone pair of what? A lone pair of what? Electron, right? So which of the following compound is a Lewis acid? It is what? Boron trifluoride. Boron trifluoride, because boron trifluoride is electron deficient. So we already looked at it here. This is boron trifluoride. This is the configuration. This is the structural representation of boron trifluoride. You can see that it is electron deficient, and so it can accept a lone pair of what? Electron. So boron trifluoride is a Lewis acid because it can accept a lone pair of electrons. And the reason for that is because it is electron deficient, right? So, having known that, let's look at the classification of acids. Well, there are different classification for acids or different classification of acids. We're going to look at we're going to look at four here, right? So the first one is organic acid. Organic acids, they are acids that are found in living things. Examples are amino acids. Amino acids. Amino acids, they are gotten from protein, right? So they are organic products. Fatty acids is also an organic acid. Ascorbic acid in vinegar is an organic acid. Lactic acid is an organic acid. Then citric acid from lemon is an organic acid. Tartic acid is an organic acid. Ethanoic acid is also an organic acid. So all these are organic what? Acids. Then we have inorganic acids. Their examples are hydrochloric acid, triazocarbonate 4 acid, triazonitrate 5 acid, tetraoxophil 6 acid. All these are what? Inorganic acids, right? Then we have another class of acid referred to as a strong acid. And what makes an acid a strong acid? It is when it ionizes completely in water. So any acid that ionizes completely in water is known as a strong acid. Examples are hydrochloric acid, triazonitrate acid, and tetraoxophil acid. They are strong acid. So let's say triazonitrate ionizes. It ionizes to liberate the hydrogen completely. So there is complete liberation of the hydrogen ion plus what? Triazonitrate ion. So this is a strong acid because it ionizes completely. The hydrogen ion constituent of it is separated completely, right? Also, if H2 tetraoxophilic acid H2SO4 ionizes, it ionizes to form hydrogen ion and tetraoxophilic ion, right? So it ionizes to liberate the hydrogen completely. So any acid that ionizes completely in water is known as a strong acid. So examples again are hydrochloric acid, triazonitrate acid, and tetraoxophilic acid. Then we have the weak acid. So a weak acid is an acid that ionizes partially in water. So it does not liberate all its hydrogen ion. For example, ethanoic acid. This is ethanoic acid. Ethanoic acid, right? And ethanoic acid is also an organic acid, right? So when this acid, ethanoic acid, CH3COOH, when it ionizes in water, it ionizes to form hydrogen ion, one hydrogen ion, plus ethanoate ion, right? So it does not ionize completely in water. It does not ionize completely. It ionizes partially because you can still see hydrogen ion here, right? So it ionizes partially in water, right? So that is why it is a weak acid. So it's very important that you know the different classes of acids: organic acid, inorganic acid, strong acid, weak acid, and know their examples. It is very important. Then also know what Lewis' definition of an acid is. It is a substance that accepts a lone pair or a lone pair of electron or a lone electron pair, right? An example of a Lewis acid is boron trifluoride. Then know what Bronsted and Lowry's definition of an acid is. It is a substance that donates a proton. So, like I said, this hydrogen chloride will donate hydrogen to this water to form hydronium ion and chloride ion. So because of the fact that it donates hydrogen to this water, it is referred to as an acid. So Bronsted and Lowry definition of an acid define an acid as a substance that donates a proton to another substance. And this is another illustration, right? The hydrochloric acid donates hydrogen to the ammonia to form what? Ammonium ion and chloride ion. So for the fact that it is donating hydrogen ion, which is a proton, it is referred to as an acid. So HCl is an acid, right? Then we looked at the general definition of an acid, and we defined it as a substance which, when dissolved in water, produces hydrogen ion as the only positive ion. So it dissolves in water, produces hydrogen ion as the only positive ion. Then Arrhenius definition defined it in terms of hydronium and ozonium ion, in which an acid is a substance which, when dissolved in water, produces hydronium or ozonium ion as the only positive ion. And we also gave an illustration of that here. Hydrochloric acid reacting with water to form hydronium ion, also known as ozonium ion, as the only positive ion, right? So this is an acid, this is an acid, this is an acid, this is an acid, right? So that will be all for this class. Thank you very much for listening.